जी अस्सलाम वालेकुम।
Walaikum salam, sir.
Walaikum salam, sir.
जी students, is there any question from the previous lecture?
No, sir.
Okay, just can you see my screen?
Yes, sir.
Okay, let me start. तो जैसे कि हमने कल कुछ चीज़ें डिस्कस की थी फ्रॉम द इंट्रोडक्शन वी आर स्टार्टिंग विद द सिंपल हार्मोनिक मोशन and what is oscillation and vibration we are discussed before and some terms associated and also simple harmonic motion with the bowl example and what is the restoring force and the motion of mass attached to a spring. Lastly we discussed this one and we also write its mathematical form. Any confusion till this point?
No, sir.
जी किसी की भी कंफ्यूजन है पूछ सकते हैं अभी तक. स्टार्ट करते हैं फ्रॉम द नेक्स्ट रिमेनिंग पार्ट ऑफ द मैस अटैच टू स्प्रिंग. तो यहाँ पे हमने फाइंड करना है टाइम पीरियड. तो लास्ट टाइम मैंने बताया था व्हाट इज टाइम पीरियड. एनी वन कैन गाइड मी?
Sir, can I?
यस.
Can I?
The time taken by the oscillating body to complete its cycle.
Yes, to complete its one cycle. Okay, starting from that formula we are focusing that there is a time period and frequency. The relation between time period and frequency is t is equal to 1 over f, or f is equal to 1 over t. Okay, as we are starting that there is a mass attached to a spring and we have to expand it and then release it. It will come toward its mean position, then it will cover a whole cycle. Then we have to find its time period. Can anyone tell me about how can we find its time period formula?
Sir, can I?
Yes.
So using stopwatch, we can just find out the time and. So you meant frequency or the time period? Sorry, I think.
Yes, we can find through frequency and through stopwatch, but it is the exact value. But we have to find some formula to just put the value and get the answer by mathematical.
Sir, the distance covered multiplied by velocity or speed.
Mm, distance and velocity. If we multiply distance velocity, what the factor become?
Sir, time.
Yes, you can get it. How can we measure velocity?
Sir, the time divided
Speedometer.
by. Yes, I said I'm saying time divided by acceleration. No, not
Okay.
acceleration. Sorry. Sorry, deceleration. No, displacement. I'm sorry.
Velocity is equal to that is d by t, and we are taking this d, and there is also a d, and there is a time. How can we get time? यहाँ पे तो और confusion होगी. हम velocity find करें या time find करें? Distance we have to measure, but there is two factor that is unknown. Number one is velocity and number two is time. How can we find these two things? Okay, we have to use just formula. It is not related to your course how to get that formula, but we have to just use it as it is. So we are taking a formula that is oscillation formula about the acceleration. Acceleration that is equal to minus omega square x. अब ये ना पूछिएगा कि ये कहाँ से आया, क्योंकि ये जो है टर्म ये फर्स्ट ईयर में आपको डिस्क्राइब की जाएगी. यू हैव टू लर्न इट इन फर्स्ट ईयर. तो ये जस्ट जिस हमने हुक्स लॉ का फार्मूला यूज़ किया था एफ इज इक्वल टू माइनस के एक्स, ठीक है, एज इट इज़ यूज़ किया, तो इसको भी हम एज इट इज़ ही यूज़ करें. तो ये फार्मूला ही है, ठीक है. इसको जस्ट फार्मूला समझ लें. मैं इसके टर्म्स बता देता हूँ. जस्ट लाइक दिस इज द एक्सेलरेशन, दिस इज द एंगुलर वेलोसिटी ओमेगा, ठीक है. दिस इज द एंगुलर वेलोसिटी and the next thing is this is displacement x, okay, as mentioned in the diagram. That is x is the displacement at any instant. Okay, now what is omega? Omega is angular frequency, and the formula of omega is equal to 2 pi f. We have to replace this 2 pi f in the first equation, then we get acceleration is equal to minus 2 pi f whole square x. Any confusion?
No, sir.
No, sir.
Okay, as we already said that f is equal to 1 over t, then we have to replace the frequency by 1 by t. There is 1 by t and the square x. Okay, moving forward, this is the just replacement of frequency. Now we can put a formula as we discussed before. तो हमने एक फार्मूला तो यहाँ पे डिस्क्राइब कर लिया, और एक हमने प्रीवियसली कोई फार्मूला डिस्कस किया था एक्सेलरेशन का. कोई बता सकता है वो मुझे?
Sir, can you repeat your question?
This is the one formula of acceleration, and we already discussed about acceleration formula in the previous lecture. What is that formula?
Sir, is it minus
Sir?
kx?
Yes, minus k x divided by m. Yes,
Yes,
I will
sir.
show it. वो slides delete हो गया जी. यहाँ पे स्लाइड्स हम डिस्कस किया था. देयर इज द फार्मूला ऑफ लास्ट टाइम हमने डिस्कस किया था माइनस के एक्स divided by m, and we said that k over m is the constant one, and we have to remove it, and we get this acceleration is proportional to minus x. Last time हमने ये डिस्कस किया था. Now we are discussing this formula, relate this formula with the formula of acceleration of this one. We have to equate both these formulas, and we get the answer that is minus k m x is equal to minus 2 pi t whole square x. Okay, and we have to cut the x on both sides, just cutting, and we get the answer that is minus k over n is minus is also cancelled with both sides, and we get the k over n that is equal to 2 pi divided by t. and we have to find a time period. Then we have to shift this time period to our left side. It is dividing here, and the left side it is multiplying. That t is equal to, and the k over m is multiplying here, and we can divide it on the right hand side. Then 2 pi is 2 pi divided by k over m. Any confusion till this point?
No, sir.
And we have to shift. Okay, there is little confusion because
Sorry?
just a minute. There's a little confusion because there is a square present there. We have to open it first, then we have to shift it. Then you can say that there is a 4 pi square divided by t square. We have to shift this t square on the left side. T square is equal to 4 pi square divided by k over m, and we have to put this m in the numerator and get the final result, that is t square is equal to 4 pi square m over k. Yes, and confusion. Any question?
No, sir, no question.
Okay, now we have to remove the square by taking a square root. Yes, we have to take a square root, and we get the final result, that is t square. Square root 4 pi square, that is m over k, and there is a 4. Square root of 4 is 2, and pi square is cancelled with the square root, that's why it is outside, and remaining terms are inside the square root, that is m over k, and there is a square of t square is cancelled with the square root, that gives us t is equal to 2 pi m over k. We get the final result. And conclusion till this point. Yes, student, any confusion?
No, sir, no confusion.
No, sir.
Okay, as we already told that there is a time period relation with frequency. Frequency is equal to 1 over t, which means that we have to reciprocal on the right hand side also. That's mean we have a formula of frequency, that is 1 over 2 pi k over m. We have to reciprocal it. Yes, we get the frequency formula.
Okay, sir.
Yes, any confusion till this point?
No, sir, no confusion.
Okay, moving forward, there is energy relation in this simple harmonic motion, and we are discussing about the two type of energy. Number one is kinetic energy. Number two is potential energy. And the kinetic energy is due to motion, and the potential energy is due to position. If we're changing position, then there is a potential energy. If we are remaining on the motion, then it is said to be a kinetic energy. In this diagram, you can say that at mean position, we are describing that there are two positions are there. There is a mean position and the extreme position. The mean position is also said to be a rest position. Okay. In mean position, you can say that there is a kinetic energy is maximum because it is start moving from mean position to extreme position. That's why the kinetic energy at mean position is maximum, and there is the velocity is also maximum because it increasing their velocity. There is some value of velocity, but there is no acceleration. Why there is no acceleration at mean position? Because there is no changing velocity. Velocity has some constant factor. That's why acceleration at mean position is 0. And what about potential energy at mean position? The potential energy is also 0 because it does not change at any position for at mean position. Okay? It does not change any position at mean position. Okay, at extreme position, you can say that it change its position from mean to extreme. You can say that there is a potential energy is maximum because it changes position, and velocity is zero and acceleration is maximum, and there is a kinetic energy is zero because the velocity is zero. Yes? Any confusion?
No, sir, no confusion.
जी, कोई और किसी और स्टूडेंट की कोई कंफ्यूजन है तो यू कैन आस्क.
No, sir.
No, sir, no confusion.
और ओके, इट इज एक्स्ट्रा इन्फॉर्मेशन और ये आप लोगों को पता होना चाहिए फॉर द एमसीक्यूज टाइप क्वेश्चंस. Okay, now moving toward another example of a simple harmonic motion, that is a simple pendulum. And as we discussed before, a simple pendulum is also performing the same simple harmonic motion as the spring doing, but a spring doing a horizontal motion, like there is a external force applied on that spring, and restoring force is due to the spring. But in simple pendulum, the restoring force is due to the weight. Yes.
Yes, sir.
Okay, now here you can see that in simple pendulum there is a small bob attached to a thread or a string, and it is hanging vertically downward. If it is straight downward, then the whole weight is acting toward the earth, that is W. And the formula of W, that is mg. And if it is increasing its velocity and goes toward the extreme position, that is here, then the weight is also acting toward the ground, that is here. But you can say that there is a tension in the string is upward, but if you can notice at mean position the tension is the above and the weight is below, then they cancel each other effect because it is remaining at rest. When it is at extreme position, then you can say that the weight will act as a restoring force. That's why the ball is moving toward mean position. That's why we can say that the tension and the weight are opposite to each other. The factor is there. We have to divide this weight into its component. आप लोगों ने 9th क्लास में कंपोनेंट्स पढ़े होंगे आई थिंक. Yes.
Yes, sir.
Yes, sir.
We have to divide it into two components, that is x component and y component. We have to draw a perpendicular line and there is a horizontal line. There is a perpendicular line, which means that that is according to this one, we can say that it is mg cos theta. Why it is mg cos theta? Because theta is lying here, mg cos theta, and there is a horizontal force, that is mg sin theta. Yes.
Yes, sir.
You can say that there is a factor mg cos theta is cancelling with tension that is above. You have to cancel it. Both these factors are cancelling, but there is only factor, that is mg sin theta, is remaining, and that is involving in a restoring force. So we can say that there is a restoring force that is derived from the figure. You can say it Fr restoring, that is equal to W, which is equal to mg sin theta. Why the cos theta is not involving? Because it cancels with the tension. Okay, and as we already said that if the motion is toward the mean position, then we have to use a negative sign here. That's why we have to use a minus mg sin theta. Yes, and can be.
No, sir, no confusion.
Yes, sir, got it.
Okay, there is the m, we have to know, and there is a g, that is 9.8 or 10, and there is a sin theta, that is unknown. So we have to find first sine theta. What is sine theta that you are telling me? What is sine theta according to perpendicular, hypotenuse and base? आप लोगों ने इसका शॉर्ट कोड याद किया हो शायद. Some people have curly brown hair. तो sin theta क्या होता है?
Sir, sine is opposite over hypotenuse.
Opposite for which?
Perpendicular by
Yes,
hypotenuse.
perpendicular by hypotenuse. And what is perpendicular in this condition? We have a triangle. We have to separate it like this one. Triangle को मैंने side पे बना दिया. So there is a perpendicular component that is here, that is related to x. We have to set that it is x, and there is a hypotenuse. Yes. तो hypotenuse को हम यहाँ पे length का नाम दे देते हैं. So we have to just put the values that we getting, that is x over L. And we have to put this sine value into above equation. We get the restoring force that gives us F restoring, which is equal to minus mg x over L. Just any confusion till this point?
Sir, I don't get the sine theta part.
Yes, sir, me too.
Okay, there is a triangle we have mentioned in this diagram. We have to clear it like this one. This is a ball, and there is another ball. Now there is the same ball at extreme position. We are making this, and there is a triangle like this one. You can take it as, and you can say that there is a position changing from mean position to extreme position. You can say that it is a distance x. Yes.
Yes, sir.
Okay, this is the length of the string, and this is a tension. You can say that there is a theta involving here. If we can say that there in front of theta, that is perpendicular. The line that is in front of theta is called perpendicular, and the line that is in front of 90, a 90 angle is here, in front of 90, that is hypotenuse. So we have to put these values in the equation, that perpendicular over hypotenuse, perpendicular is x, and the hypotenuse is r. Clear?
Oh, sir. Okay.
Okay, sir.
Okay, next one, you can say that we have to put the value and we get the answer, and like previous one, we have to say that there is a force involving here, and what is the formula of force? That is a normal force. You can say that that is ma is equal to minus mg x by L, and they cancel both the side m, and we get the acceleration minus g divided by L into x. You can notice that this length of string is remain the constant, and the value of g is also constant. We can put a constant here like the previous one. Yes.
Yes, sir.
Okay, acceleration, we have to remove this equal sign and the constant. We get the proportional sign. Acceleration is proportional to minus of x. This is the main simple harmonic motion. We can prove it through this method. There is a simple harmonic motion is also present in a simple pendulum. Get it?
Sir,
Yes.
Yes, sir.
G is constant. Sir, and the L.
L is the string length. We are not
Oh.
changing the length of a string that is attached with the bow.
Okay, sir.
That's why it is also a constant value. but the x is changing because it is a displacement from extreme to mean, and from another extreme the value is changing. That's why x is unknown, and g and l are constant value. Okay.
Okay, sir.
Yes, any confusion?
No, sir, no confusion.
Okay, like the previous one, same the method is applying here. We have to put the time period, that is 1 over f, or f is equal to 1 over t, and the acceleration formula, that is minus omega square x, and there is omega, that is 2 pi f. We have to put the value, acceleration equal to minus 2 pi f square x, and we have to put the frequency value, acceleration, that is minus 2 pi divided by t whole square x, and this is the acceleration formula. And we also find the previous one, that acceleration formula, that is minus g over l into x. We have to compare these two equations. Minus g over l into x is equal to 2 pi divided by t minus whole square into x. X is cancelled with on both sides, and the minus is also cancelling. We get g over l, which is equal to 2 pi divided by t whole square. And we are getting, opening the square, that is g over l, which is 4 pi square divided by t square. We have to shift like the previous one, t square is equal to 4 pi square divided by g over l, and we have to move this l in the numerator, that is t square is equal to 4 pi square l over g, and we have to take in the square root. On both sides, t square, which is 4 pi square l over g over the square root, and we have to cancel the square root with the square. T is equal to square root of 4, that is 2. Square of pi square is cancelling with the square root, that is pi, and the remaining terms are in the square root, that gives us 2 pi l over g. Any confusion till this time period?
Sir,
Yes.
sir, at this point g divided by l, sir, can we just take 4 pi square to the left side and not take the t square to the left side? That would be same, I guess.
Yes.
So, sir, I
But
can do
if
that
we
with.
are not moving t square toward the left, then it is in the denominator. But we
Uh,
get, yes,
okay, sir.
that's why we are moving this t square toward the left side.
Sir, but the t will be left alone when we'll take the 4 pi square on the other side, I guess.
Yes, but is it in the denominator?
Okay, sir.
Yes.
Okay, I get it.
And we have to find in the same frequency formula, like t is f is equal to 1 over t, which is equal to 1 over 2 pi g over l. We have to reciprocate. Any confusion?
No, sir, no confusion.
Okay, this is the end of simple harmonic motion, but the simple harmonic motion is the continuous motion from mean position to extreme, and extreme to mean, mean to another extreme, and extreme to mean. This is the whole complete simple harmonic motion. But if we are dealing with a practical case, not an ideal case, then we are discussing about a damping effect. And what is damping effect? This is opposite to the oscillation. The oscillation is remaining constant, but it in damping effect it become rest. Okay, In a damping effect, you can say that the oscillation of the system is in the presence of some resistive force. This is some resistive force which resists the object to move. Yes, to stop it. Just why it is? Because if you are taking a home example, you take a ball and the ball, you have to take an example and move it toward the mean position, then it will stop after some time at the mean position. Yes?
Yes, sir.
Yes, sir.
That is the damping effect. We have some resistive force according to Bowl. That's why we say that this is a damped, and we say that graph is showing here. If the wave is continuous its motion like this one, then it is undamped. When it is like a decreasing its amplitude like this one and becomes zero, that is the damping effect. And it is helpful for a shock absorber in the car or a bike in like a truck. How it is important? Because in a shock absorber, the shocks are present here, looking like a piston. It has a liquid present here. If we have a jump or a ditch, you can say that the car is jumping continuously for some time and remains same on the road. You can say that if there is a jump in front of a car, yes, then you can say that if the jump is present, the car is moving and the jump is absorbed in the shock. If the shocks are very good condition, then the jump is not feeling like that one. जिस तरह अक्सर आप देखते हैं ना कि अच्छी गाड़ियां जो आप यूज़ कर रहे होती हैं तो उसमें क्या होता है, अच्छे शॉक्स लगे होते हैं तो वो एब्जॉर्ब कर लेते हैं मतलब उस शॉक को एब्जॉर्ब कर लेते हैं, दैट ऑब्जॉर्बिंग दैट शॉक.
Yes, sir.
Yes, sir.
ठीक है, तो गाड़ी एक जंप लगाती है और जंप के थ्रू वो बेसिकली उस शॉक को एब्जॉर्ब करती है और अपने टायर को एक पुश देती है. ठीक है, पुश दे के वो बेसिकली क्या करती है, आहिस्ता आहिस्ता गाड़ी को स्टेबल करती है और आपको थोड़े से मतलब उसको कहते हैं ना जर्क लगती हैं, छोटे छोटे झटके लगते हैं गाड़ी में. तो वो ऐसा ऐसा जंप करके रिमेन द सेम ऑन द स्मूथ सरफेस आ जाती है आफ्टर जंप. For undamped condition, what is undamped condition? It is the oscillation in the absence of a resistive force. It is the ideal case, but the damping effect is a practical case. Yes.
Yes, sir.
Yes, sir.
Any other example you can give damping effect? Yes. Any other example? No one?
Sir,
Yes.
sir, carpet pads.
How?
Uh,
How? Okay, I will give you some example like in a gym. Gym, that is GYM, not a gin. लास्ट क्लास में मैंने जिम बोला था, उन्होंने जिन समझ लिया. That is gym, GYM.
Okay, sir.
Okay, in a gym there is a heavy load lifter, and at the bottom of heavy load lifter there is a springs present. That spring is doing the same effect of damping. Okay.